All right, guys, are there any questions on any of the assignments thus far? Okay. If there are no questions on any of the assignments, today we're going to be looking at using midsegments of a triangle. A midsegment of a triangle is a segment that connects the two midpoints of two sides of a triangle. Every triangle has three midsegments, which form the midsegment triangle in the middle. So if we look at this here, the midsegment triangle is the one in red. Stick with red then. This one right here. And the midsegment of triangle ABC is these here. And what's interesting enough is that these segments, MN, is going to be congruent to BP and PC. Those three segments are actually congruent to each other. We can also say that AN, NC, and MP are all going to be congruent, and AM, MB, and NP are actually all congruent. So when we connect these three midsegments in the triangle, we actually have four congruent triangles in this figure. One of the other interesting parts about the midsegment is that the midsegment connecting the two sides or connecting two midpoints of a triangle is parallel to the third side and is half as long as the third side. So the distance from D to E is equal to half the distance from A to C. So whatever its length is, it's half of it. So really at the midpoint between A and C, we can call it F, would be the same as these three here. Because the distance from D to E, if we added it twice, would give us the entire length of AC. Any questions on this here? All right. Let's look at cafeteria trays. In exercises 11 through 16, XJ is congruent to JY. YL is congruent to LZ. And XK is congruent to KZ. Complete and copy each statement. So we're just going to complete the statements. So JK, this line here would be parallel to what other line? Not LK, because this line here would be parallel YZ. Because it's going to be parallel to the third side. This would be parallel to the third side length. So those two sides would be parallel. Now J, huh? Yes. And we'll need to use the two endpoints. Is JL and XZ, because since we're not talking about the full line, we're talking about the segment, we need the two endpoints. Any questions on this here? Well, we do have the third set, so here XY would be parallel to KL. These two here would be parallel to each other. Now in the diagram, it did tell us that XJ and JY are congruent. YL and LZ and KZ and XK are congruent. Now JY JX would be congruent to it. And the reason that we can say KL is because I know that KL is equal to half of what? XY, yes? Because KL's length is equal to half of XY. Well, what is half of XY? So we can say that those two are congruent. Those segments would be congruent. Don't really need to put that. But those segments are congruent. Well, if those two are congruent, it has to be congruent to JX. Those two are all going to have the same amount, the same value. Questions on this here? Too far. So let's look at this one here. Well, it's asking about JL. Yes. And KZ. Because it's half. Because we know that these two are going to be congruent. And this is equal to half of the whole length. So those three are all going to be congruent. Questions on this here? Next one is JK. JK, YL, and LZ. Any questions on this here? Do we like this here? I can tell you 100%, with 100% certainty, there will be a problem exactly like this here on the test. So the naming the three sets of parallel lines and naming the congruent segments. We ready for what's next? So we said the mid-segment, DE is a mid-segment of the triangle ABC. Well, the mid-segment's equal to what? Half of the third side, yes? So that means here, x is equal to half of what? 26. So the value of x is 13. So really we're saying the mid-segment's half of the third side. Half. Or really we can say what? That the third side is equal to what? Twice the mid-segment. Because it's just going the other way around. So here, the way that we set up the last one, we would be saying that the mid-segment 5 is equal to half of x, because the mid-segment's equal to half of the third side, yes? Well, what would we do here to solve this? We need to get rid of the 1/2, yes? There's two ways we can do it. What is one of them? What can we do to both sides? By? Yes. Or what could we do instead of dividing by 1/2? Because we can multiply by 2. Because 2 times 1/2 is what? 1. This would be 1. 5 times 2 is 10. So we could do it that way, or we could say that the mid-segment, or the third side, is equal to twice the mid-segment. Either way, we'll get to the same answer. Any questions on this here? So DE here is a mid-segment, yes? What are points D and E on the triangle? Each one of these is a mid-point, yes? So it's the middle of the line. So what do I know about BD and DC? How about AE? they'll get a little more challenging here in a minute. Questions on this here? Because the mid segment, yes. If it was AC was 8, then DE would be 4. But because it's talking about the sides, E is a midpoint, so these two would be the thing. Any other questions on this here? Because EC is, and it wants the whole thing, so we can do 4.8 plus 4.8 or more multiplied by 2. 9.6, so AC would be 9.6. So these are all mid segments. Now they tell us AB is 3x plus 8. In GJ, the entire segment is 2x plus 24. So we could say, use that AB is equal to 1/2 of GJ. And this will work just fine. Because what is GJ? What's this equation? 2x plus 24. Is 2x and 24 both even? So we can multiply by 1/2 and get whole numbers, yes? So let's do that. Because if it works out nicely, we can use it. Equals 1/2 of 2x plus 24. We would need to distribute the 1/2. This here would still be 3x plus 8. 1/2 times 2x is 1x, because 2 times 1/2 would be 1. We're dividing by 2. 24 divided by 2 is plus 12. Let's go with a different color. Yes, we can subtract 8 from both sides, which would tell us that these would cancel, and we'd have that 3x is equal to x plus 4. And then what? Subtract x from both sides, yes. So 2x is equal to 4. And last but not least, we would divide both sides by 2. And what was it asking for? The length of AB, yes? So any questions on how we got to 2 before I scroll back up? Well, AB is defined by what? 3x plus 8. And what's the value of x? So AB is. So this is one of the few that we've come across where the segments weren't just straight equal. We actually had to multiply by 1/2. Questions on this here? Let's see what it says here. It says that AC is 3y minus 5. And HJ is plus 2. What is the value of HB? It'll be that same value. Because, yes? Yes. And luckily, the bigger side here, HJ, is 4y and 2. They're both even values. We can divide by 2 nicely. And the first thing we would need to do is to distribute the 1/2. Which would tell us that 3y minus 5 is equal to, well, 1/2 times 4y, or 4y divided by 2 is, and 1/2 times 2 is plus 1, because 2 divided by 2 would be 1. And at this point here, we can subtract 2y from both sides. When we subtract 2y from both sides, we would get y minus 5 is equal to 1. Exactly. We can add 5 to both sides, which tells me y is equal to 6. And to find the value we want, we'll plug the value of y into where? Into the 3y minus 5, which would be 3 times 6 minus 5. Well, 3 times 6 is, and 18 minus 5 is 13, so HB is 13. Questions on this here? Okay. I believe this is the last one, yes? So we can set it up like we did before. CB is our smaller length, so we'd have 4z minus 3 is equal to 1/2 of, try to draw z first, 7z minus 1. Why won't this work as nicely? We do have odd numbers, yes? 7z and 1 won't divide by 2 evenly, will they? Okay. I'm going to erase that. Now, what we do know is that CB is equal to half of GH, yes? Didn't we have another way to write this? We could say that GH was equal to what? Times CB, yes? Wait a minute. Does this deal with having to divide anything by 2? So would it work better with this one here? Well, yeah. So what we could say this time is that 7z minus 1 is equal to 2 times 4z minus 3. Will doing this also have worked with the previous problems? Well, yes. Almost. Back up. So this time we're not multiplying everything by 1/2, we're multiplying the one side by 2, which would give me 7z minus 1 is equal to, well, 2 times 8, because we're multiplying by 2. Yep, that's fine. Well, not so much, but I get where the mistake came from. 2 times negative 3 would be negative 6. Now what do we do next? Right, we would need to get them on the same side, yes? We can do that by subtracting 8z from both sides or subtracting 7z from both sides. I'm inclined to subtract 7z, mainly because 8z minus 7z would be a positive 1z. If we do it the other way, we would get a negative 1z. We would still get to the same answer. We would just have to deal with the negative z, making it positive again. Now what do we do next? Add 6 to each side. 5 equals z, or we can say z is equal to 5. So we can, or we could plug it into. So we can do that. Let's do that. 7 times 5 minus 1. Well, 7 times 5 is? Minus 1 is 34. So this would be GH. Now, GA, the smaller section, would be divide 34 by 2, and we would get 17. Now, if we did 4 times 5 minus 3, 4 times 5 minus 3 would be 20 minus 3, which is 17. So we could have gotten it either way. Any other questions on these mid-segments? We like mid-segments? But that's it. And the reason I sometimes stick with this one, because then I don't have to worry about being divisible by 2 and dealing with decimals if they're not already present. And that's it. So there's not an actual physical or an assignment out of the book. There is a worksheet that is attached with this one here. Well, yes. There's a good chance you could probably work on them and finish them in class. You'll have more than enough time to finish them up.